Hey everybody, and welcome back to my YouTube channel. Today we will be doing question 22 on AMC 8 2020. Now this question is a bit more of a conceptual problem, so if you understand the concept behind this question, it will be really easy for you to solve any variation of this question. So let's read the question first. A game board consists of 64 squares that alternate in color between black and white. The figure below shows square P in the bottom row and square Q at the top row. A marker is placed at P. A step consists of moving a marker onto one of the adjoining white squares in the row above. How many 7-step paths are there from P to Q? And on the picture, it shows a way of getting from P to Q. Okay, let's read the question again, but let's underline some keywords. So, first of all, game board consists of 64 squares that alternate in color between black and white. The figure below shows square P in the bottom row and square Q in the top row. A marker is placed at square P. A step consists of moving the marker onto one of the adjoining white squares in the row above. How many 7-step paths are there from P to Q? So 7 steps, adjoining white squares, and row above. Okay, so what does this mean? If you're going to move from P, you can't go from, say, P to here directly. You can't go like that directly. You have to first move to, say, this square, and then you can move from this square to this square. But because you can't move from this square to this square since they're not adjoining. You can move diagonally though, or the other way diagonally. Now, how many 7-step paths are there? So this is a 7-step. 1, 2, 3, 4, 5, 6, 7. All right, so the first thing that we can do to start off this question is to find a range of which it's sort of the widest it can go, but it's still 7 steps and it reaches Q. So yeah, sure, we can go like 1, 2, 3, 4, 5, 6, 7, but can we go one further? 1, 2, 3, 4, 5, 6, 7. Yeah, that makes sense. But you can't go any further because if you go to here, there is no way that you can come back to here without touching the black square. So we know that this is sort of the range, and we can highlight it or make a mark. So we know that we can't go past this range. Okay, there we go. And now we can try to solve the problem. Now this is what's known as an irregular pathway. And keep this word inside your head because we're going to be talking about it later. So, how many ways are there to get to P? Well, we're already on P, so that means there's one way. How many ways are there from P to get to this square over here? 1. There's only one way. You can't go to this square because you would have to touch a black square. But you can go to this square. There's only one way. There's only one way to go here and one way to go here. There's also only one way to go here. Now, how many ways are there to get to here? Now, this is where it first starts to get difficult. So, you can either go here, here, or you could go here, here. So, how many paths is that? That's right, 2. Now, what about this one? You can go like this, or you can go like this. Is that 2? No. It might seem like 2, but it's not. Because since there's 2 ways to get to here, so there's already 2 if you go to here. But then there's one more, so that would actually be 3. Now, you sort of just add on, so it's like, 2 plus 1 equals 3. So then here would be 3. What would here be? That's right, 1 plus 3, which gives you 4. This would be 6. This would be 10. This would be 3 again, because the only way you can get to here is like that. This would be 9. Ooh, let me scroll up a bit. This would be 19. This would be 9 again. And this is 28. Now, is 28 an option as an answer? Yes, it is. It is option A, which is correct. Now let's move on to the concept of pathways. So there's two. First one is regular pathways. This might not be an exact question which you might see, but it's a good concept to keep in mind. So let's say this was P, or this was your house. And this is school. So, how many ways are there to get from here to here by only going in this direction or this direction? All right, so first of all, there's one way, just like we saw in our problem here. And there's obviously only one ways to get to here. But how can we get to this particular intersection? Well, we can either start from here, go like this, or we can start from here first to go here and then here. So how many is that? 2. Right. How can we get to this intersection? We can either go from here down to here, or from here down to here, down to here. Now that's 3, because there's already 2 ways of getting to this intersection. And if you're going to move from this intersection to this down intersection, which we want to figure out, you would have to do 2 plus 1, which is 3. Now, if you keep going with this pattern, you will find that the answer to this question will be 56. Now, I'm not going to waste any more time just doing addition and solving the question, but I'm going to teach you another way of solving the pathway questions quickly. So, what we can utilize is a factorial. So, how does this work? First, figure out what by what your grid is. So, in this case, it's a 3 by 5 grid. So, what's 3 plus 5? It equals to 8. So, essentially, you're going to have a fraction. On the numerator, you're going to put 3 plus 5 bracket factorial. And on the bottom, you're going to put 3 factorial and 5 factorial. Now, what does that give you? That gives you 8 factorial divided by 3 factorial times 5 factorial. Now, you can move downwards and you can see 8 factorial equals to 8 times 7 times 6 times 5 times 4 times 3 times... Why is it not working? Time. 2 times 1. Okay, now 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. Now, you can first cross all of this off in exchange for this, and you can cross these off for that, which will give you an answer of 56. Okay, now let's move on to irregular pathways. So we've already gone through this in the question here. So essentially, it's just a shape that's not a complete grid. It can be in any shape. It can be in triangles, rectangles, hexagons, pentagons. It doesn't matter. But all you have to figure out is your starting point and your ending point. And how many ways are there to get from this intersection to that intersection? Make sure that you understand that you cannot go backwards unless the question specifies so. So see, in this question, it states that you have to in the row above. Therefore, you cannot move back down and up again to find a better spot. So that basically being said is that this irregular pathway can be in any formation, that it could be in just not as a regular grid, and you have to make sure that you understand where your starting point is and where your ending point is and work from there. Start little and grow out like a tree, so it's like organized, and you just keep adding and adding until you reach the final destination, and then you can brush it through to see to make sure you have every single point accounted for, every single intersection, and then add them all up, and then you will get the answer, just like we did here. Thank you so much for watching, and I'll see you at the next one. If you have any questions, make sure to email me at my email account, or you can comment down in this comment section below. Thank you so much, and I'll see you next time.